scale factor to enlarge something, right? Like a figure of some sort. Well, that is a type of transformation. Now, let's see what you think about this. I mean, it ain't triangle. What do you think about that? It's pretty funny. Let's see. Jorge, what do you think? What does this picture represent?
Reflection.
Why do you say it's a reflection? Because of what? Oh, because of the mirror? Is there anything else other than a reflection, Jorge?
I don't know.
All right. No more. Does it me or does this look bigger in the mirror or does it look smaller in the mirror?
It looks smaller. I mean, it looks bigger in the mirror. Bigger in the mirror.
We're looking at a small cat here, and in the mirror he looks like he went to worked out a lot.
Or that's probably what he wants to be. For the small little cat.
All right. Tatiana? Joel? What does this look like, Joel?
Reflection.
And you say that because
In the mirror, if you put words next to it, it goes like in the other side.
they're like backwards?
Yeah.
Jonathan, do you agree with what he said?
Yeah.
And this one, I mean, it's hard to tell, but it is something you haven't seen before. Adrian? Adrian, you? What does this look like?
Translation.
Why would you say it's a translation?
Because that one's they're in different positions, but they look the same.
Okay, so what would it, if this was the original figure, the original figure, what would the translation be? Would it be translated up or down? Down? Does it look like it's more than a little down? Like it's kind of shifted other than down? The right or the left? Or if this is the original, he's down. You're right. He's down. Is it to the left or the right? It looks like he's going a little to the left to me, but I mean it's hard to tell because it's like right on top of each other. But as you can see, translation can either be down or to the left or to both. Oh,
Okay, so in the next activity, what we're gonna do, it's gonna be a paper that looks like this. And in groups of 3, what you guys have to explain to me, you have to explain to me what is going on in each one of these pictures from this side to this side. You need to explain. So, for example, number 1, you need to explain what happened when this graph changed to this graph. And we're going to do it in groups of 3. So what I'm going to do, you guys are going to number off. You guys are going to number off to 3.
1, 2.
1, 2, 3, 2,
3.
Okay. Actually, can we recount? I'm so sorry. We need to count to 7. I'm sorry.
1, 2.
4, 5, 6, 7, 1, 2,
3,
4, 5, 6,
7,
8.
Okay, I need the 1s here, 2s here, 3s here, 4s here, 5, 6, and 7.
Man, where's the 7?
Put over there.
Twos, right?
Over here.
Pull your chair over here.
Right there.
Tyler, what are you? 4? Where's the other 4s?
Yeah, where are you? Just 1, 2, 3, 4.
There's too
The
many
4
of y'all.
should be here.
Too many of y'all at the back table.
What's your number?
7.
What is
You're not a 7, Victor. You're a 4, Victor. Yeah, you're a 4 pumpkin.
Right.
Because he was 1, 2, 3, 4.
You ready? Okay, so in your groups, I need you to go ahead and work together on problems 1, 2, and 3. Okay, get started. And you guys have about 3 to 5 minutes to complete this. Just describe what's happening. Guys, you don't necessarily have to know an exact word, just describe what's happening.
Okay.
You all can work together. When you're done with
Yeah.
yourself, come together and say, all right, what do you do? Yeah, and then work together.
I know it.
All right. Go on the group, so if anyone has an opinion about something, you all can talk about it. Can you say again that the right shot? What do you all think about the first one? How do you think it's going? But we did it That's not, it's okay. Why do you put it up around the school? If they get moved up and then moved up and then left, What's your opinion? Y'all are come together and help. How about what you think is going on? We all have the same idea.
I'm trying, and I noticed that a lot of groups had somewhat similar things and then somewhat different things. So in number one, what changed in number one from this graph to that graph, Mr. DeMontre? It was a reflection. Why do you say that the number one was a reflection? So you're saying this graph and this graph, they were pointed in opposite directions, so it was a reflection. So almost like a mirror somewhat. Okay, great job. Alright, so what changes are happening in number 2? Brandon.
Well, in the first one it's like smaller, and in the second picture it shows that it's bigger.
So it shows that it's bigger. So do you like see any similarities in the triangles? Like are the triangles still similar since since it went from small to big?
I think they're so similar because they're the same shape.
You think they're similar because they're the same shape? Okay, did anybody else get anything differently? Victor, how about you? How about you for number 2? What type of changes are going on in number 2?
They're smaller and the other one's bigger.
One's smaller and one's bigger. So, what type of changes are going on in number 3? Ariana.
The translation, because the first shape is like right there, but then the second one is just like moved upward.
So did the shape change any?
No. Still the same.
Great job, guys.
This is an easy question. Oh, some easy questions. You all said one was a reflection, right? All right, what happens, all right, who's reflecting? Like you all know the axes, right? Like this is your x-axis, this is your y-axis, right? Okay. So Michael. Right, please?
Yeah.
Michael, what axis is doing the reflecting? Or is it being reflected over here on this number 1? If you were to say it was.
Y-axis?
Okay, you're right, but why the y-axis? Because, here, I'll get you to come up and show me, because it's kind of hard to say visually. Alright, point to the y-axis so everybody knows where the y-axis is. Okay, so there's your y-axis, and it acts like, remember in the picture of the cat? Yeah, so it acts like a mirror, and then thanks, Michael. For number 2, here's for number 2. You all said it got bigger, right? So Clarissa, what if I was going from? Clarissa, what do you state this as? Is this some kind of transformation, or that you know of?
Well, I forgot the word that Ms. Cole said it was a swing, but it didn't work.
Right. So if I was to say,
He said this swing like for it. I forgot what he said, but I think it was.
Okay.
all right. So if I'm going from, Chris, if I'm going from here, if I'm going from the right to the left, is it getting bigger or smaller? And then if I go from the left to the right, it's getting.
No.
Number 3. Francisco?
He's not here.
Francisco ain't here again. Mariana? Mariana here? Alright, Mariana, what if I said, number 3, you said, what did you say number 3 was? Translation? All right, if I was to translate, if I was to go from here to here, this is your starting, this is your ending, what would the translation be? You can say up, you go up and down, left and right.
No.
You don't have to say how many units, just tell me where you're going. You're going from the right to the left. Where does he have? What directions does he have to go? Right, so it has to go down. And then where? Is there any other direction? So you're saying if this guy just went down, he'd be the same as him. All right, Demandre. Did I say that right? Demandre, what do you think? All it has to do is go down. What do you think?
I go to left.
So it goes down, and then to left, but it can go either way. Whenever it starts, doesn't matter, does it? Like if do you have to go left and then go right, or can you go right and then left, or does it matter? Do you have to choose a direction when you're doing this? When you're going directions? You know? Alright. Jonathan. Jonathan? Alright, Jonathan, do you have to choose a certain direction? Do you have to go right first and then down, or does it not matter? Why do you think it doesn't matter? That's exactly right. If you're going to go up and down or left and right, you get to the same spot, it really doesn't matter, because that's what translation is. All right, so let's talk about those terms we were discussing in the activity. Dilation. Oh man, I just got what do you all think the dilation means? Like, oh, Harold, call the name. Joel? Keep saying that. Sorry. Joel, what do you think when you hear dilation? It means two things. I mean, it's a tricky one. Not anymore? Like, if you think about it, if you hear dilation, like, what do you think of when you hear dilation? You ever been to an eye doctor? You know what a pupil is, right? So that little black spot in your eye? Well, when you go to an eye doctor, they put a dot in your eye. And so they can work and looking better in your eye. And this drop they put in, it makes your pupil even bigger. And that's what they call a little dilation drop. So it makes it bigger. So I mean, when you think of dilation, you can think, all right, well, the pupil's getting bigger. That's a dilation. So if something's getting bigger, already you know something's getting bigger, it's dilating, right? All right. Titania?
No, here. Graciana. She got it today.
Jose? All right, what do you think of when you hear a dilation?
Well, one's smaller, one's bigger.
One's getting smaller, one's getting bigger. What's the key, I can't say, I don't want to say a word, but I can't say, what's the key thing that makes it smaller or bigger? You've all learned it now. I think it's on the board, it's over there.
Scale factor?
Yep, scale factor. What does scale factor mean? I mean, if you don't know what, if you know what dilation is, you gotta know what scale factor is, right? So what is scale factor? It's like a number that judges if it gets bigger or small, right? All right, so move on. I keep picking the same names. Demandre?
Robinson or Bacon? Is it a Trey or a
Dre.
Mondre? Bacon.
All right. What do you think of when you think of a reflection? It's like a flip. It's like when you ever woken up in the morning or like about to go out and you look in the mirror and everything, like if you have like a shirt that has letters on it, what happens when you look in the mirror? It's backwards because it's Exactly. All right, Ariana. All right, what do you think of? Oh wow, that thing's like kind of in the way. Well, that did not help. All right, what do you think of when you? I know. Well, I want to hear your first definition because translation is some. When you think of the word translate, you have never heard of math. What do you think of? Yeah, but when you think of the word translate, like in regular language, like what do you think of translate? Like
Like speaking English and translating Spanish.
Yeah, it means like going from one thing to the other, right? So it means something slightly different when we're talking in like real terms. Like if you're going from English to Spanish or English to Portuguese, that's translate. So let's Deasia, what do you think that now that we know what translate does in math, what do you think translate means? Slide? Describe slide, like, because so like, what kind of directions are we talking about here? Okay, Victor, what do you think translation means to you?
Say something. Translate something.
Translate something, but if you had a word for translate, what word would you use? Like if you had a box and you wanted to put it in another position, you would have to do what to it? You would have to move it, right? It's like a movement, right? All right, that's good. Revon. Rihanna? Alright, so do you think all these terms can be, like, all these transformations can be used in one fell swoop? Like, if you were to see a figure and it was, do you think you could use all these? How so? Sure.
I'm not sure.
It's okay, Clarissa? Clarissa, what do you think? Could you use all these? Could you use a dilation, a reflection, and a translation if you wanted to? If I gave you a triangle, like the one, I don't think it's there, but if I give you a triangle, like the one on those sheets I gave you, do you think you could use all of these with that triangle?
No.
Why not?
Because I remember that you said that a translation has to be the same shape and the same size in order to do a translation. And if you in the dilation, you can make it bigger or smaller. So I don't think those are the same.
That's actually a good input. Francisco? All right, what happens, like what she said, but what happens if you, like she said it has to be the same size, you're going to do a reflection, right? So what happens if, just saying if here, before you did any enlarging to the figure, if you translated it, could you use all three?
Yeah.
So, okay. Jonathan. Oh, sorry. Do you think order matters when it comes to using, if you were to use one of these, or all three together, does order matter?
I think so. Reflections are different. Move it around, then make it bigger.
Okay, so what she said about reflection, what is that? Does reflection have a big factor in the whole order of things? Because reflection means like you take a figure and then it has to be the same size. But you can't take a figure and then make it a different size, right? All right. This is the last thing we're going to do today before we have to leave. But reflection is a really hard thing to learn. So what we're going to do is we're going to go through a reflection example. All right, so I'm going to have one person come up here and help me with each part of these, like A, B, C, and A prime, B prime, C prime. So raise your hand if you want to. Anybody want to write on the marker board? All right, I'm going to call names. Joel. I said I'm going to call names. So raise your hand. All right. All right. What is a prime? I didn't say what B and C were, but just think of B and C. Think of this is your B and this is your C. So what is A? Because it has a little A over here and A prime over here. So what are the coordinates for A? 2, 2. How'd you find that? Yeah, no problem. But how'd you find it? You have to show us how to use it. 2. Oh, okay. I'll put it in. All right, so everyone agrees that it's 2, 2, right? Does everyone agree it's 2, 2? All right, you know that. Oh, you know that. All right, I'm going to call, anybody raise your hand or else I'm going to call a name. I'm not sure. Anybody want to raise their hand this time? All right. I'm just going to call random names I remember. All right, for B, what is B? Remember the one that are connected is C. So yes, that is B. So what is B?
I say 2, 0.
2, 0. What did you? I mean, he showed me direction. Like, how would you figure it out?
Well, to get from here, you gotta run before you go up the ladder. So you go 1, 2, and then you didn't go up, so it's 0.
Run before you go to the last. Really, it's a good one. All right, so we'll write it down. It's 2, 0. Okay, anybody else want to volunteer? No. Okay, Deasia. All right, C. C is the last one left, right here. What is C? C is a tough one. I think it's it's not tough. It's not tough. Okay, so how did you get 0, 0? What is? I mean, in math terms, I know you all know what the term is. So what is C? And if you look at the graph, C is the 0, 0. What is 0, 0? Never heard? Anybody heard what 0, 0 be called? The middle of a graph. It has a name for it. Anybody know? What? Just for an O. I've heard origin, and you're dead right. It is the origin. So 0, 0 is the origin. It's where everything else originates from. That's how we get origin. So good job. All right. So now let's go on to the primes. Now, who wants to do the primes? Anybody gonna raise their hands? He suggested that you go so well. Megan?
Oh, your brother went up there. You can do it.
Where are they?
Right there. So, all right. So what is a prime? Negative 3, 3. All right. Negative 3, 3. Go 1, 2, 3. 1, 2, 3. And that's A prime. A prime, I meant was, I know the letter's a little off, but this point right here. So what is A prime? Okay. Sort of that. All right. Anyone else want to raise their hand to volunteer? This time I'm just going to go around and hand somebody a marker. And here, have at it. Anybody want to go? Fun. Here. Why don't you go on? Yeah, I know. Fun. This is fun to be. B prime. Where is B prime? The ones that are touching each other, right here, that's C prime. So where's B? This is A.
-2 and yeah.
I don't know, is it? I'll give you a hint. You run before you rise. You ever heard of the phrase rise over run? No? Okay, well.
Brandon, put your pencil on the origin. Put that marker on the origin. Okay. Show him how you got -2, 0. Where did you get that from? Did you go backwards 2 places? Huh?
Well, I mean, I figured just because, because right here, kind of like the same measure, but it is one of them is negative.
Okay, hey, put it back on the origin. Put your pencil up there on the origin. Go backwards to where B is. And how many times did you go backwards?
2.
Okay, so that's right. That's where your -2 came from. Did you go up or down? After you went backwards to the B?
See where, did you go up or down, or did you just go to the left? See, if this is B prime, did you just go left, right? Point right here is B prime.
Okay, put it up there where B would be, Brandon. Now, are you going to go up or down, or are you just going to stay put now? You had it right, Brandon. Just answer everybody. Did you go up or down now? After you got right there, are you moving anywhere else?
To get back to the middle, would you go left or right, or?
Brandon, put it right there. Hey, you got it. Don't stress out on it. Put it right there. No, there. And am I going anywhere else, or am I staying put? I'm staying on. Oh, there you go. That's why you got the 0, baby. You're right. Don't stress on yourself. Don't second guess yourself. You're right. You had it right.
Got it right. Good job, though. All right. Who wants to go for C prime? Anybody want to go for C prime? You want to go? All right. Finally, a volunteer.
Oh, yay, Frankie.
All right. C prime.
Wrong.
0, 0. And what is 0, 0? What's the name for? We just talked about it. Maybe a minute ago. There you go. Origin. So why? All right. Here's the question. While you're up here, why don't you tell me C and C prime? Why didn't they change?
Because they didn't move.
Because when you what happened during when you're reflecting something, it's switching axes. So what exactly happened in your words? You said nothing happened. So when you reflected, nothing happened. All right. So let's look at these points. We got 2, 2 for A, -2, 2 for A prime. Does anybody see anything a little peculiar about this? There's a pattern. But I'm just wondering if anybody sees any patterns. No more? All right, so what's the difference between 2, 2 and -2, 2?
On -2, 2, one of the numbers is negative.
So did it change from a positive to a negative, or a negative to a positive? So it changed from a positive to a negative, just because you flipped it over the y-axis. All right, so Francisco. I don't know. You got it right. B, 2, 0. And then B prime is -2, 0. What's the change? From 2, 0 to -2, 0.
Oh, and just reflected to the side.
So what does that mean though for B prime? B going from B to B prime. All right, Jonathan. What does that mean going from B to B prime? What happened? What changed? Okay, so it changed the next. Has anybody seen a pattern here? All right, let's see. Rian, what pattern do you see a pattern? What's a pattern?
The first number is a negative number.
It is a negative number, or it's changing to
It's
it?
changed to a negative number.
So it's changing to a negative number. And anybody know why it's changed to a negative number? Clarissa?
Because a reflection is like, it stays in the same place, but it's just reflects to the other side, so it's going to be the same measurement or whatever you want to call it, because it just changes like the shape didn't get bigger, smaller. So yeah.
So why is it changing to a negative?
Because it's on each to the square, because it's like positive, positive, negative, 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 positive, and it just happened to be on the negative and positive side. So yeah.
So, all right, because the size have changed, it changed signs. All right. Well, that's all we have for you today. Next time in class, we'll go over more examples and more models of other transformations, but hopefully you all learned a lot today. We'll see you all next time.